Hello class, I just want to walk through some of the things that were covered in the PowerPoint and how we can do them in Excel. So here we have an example of some ordered pairs, hours spent studying, and associated test scores. This column would represent our X values, and this column would represent our Y values. So the first thing we'll do is create a scatter plot, and very simple. Like other graphs that we've created, we're going to highlight our data, our column, X and Y, and we're just going to say insert, and right here you can see a bunch of little dots. I imagine if you went to recommended charts, you would see that under all charts as well. Do I see it? I do see it right here. So multiple ways to get to the same thing. I'm just going to pick a regular old scatter plot, and there it is. So you can see that, for example, our first ordered pair 040 is represented right here by this dot. Our second ordered pair 251 is represented by this ordered pair. So it just plotted our dots for us. And we can see that it kind of looks like there is some sort of a correlation. It looks like it's a positive because it's going up, and that there is some semblance of a correlation going on here. But to prove that or disprove that, we are going to calculate our correlation coefficient, which is also represented by the letter R. The variable R is just your correlation coefficient, and that's where that formula that we looked at on the PowerPoint that was quite messy looking, well, we can do it in Excel just using this formula right here, equals CORREL. So I'm just going to start typing that in. It'll come up for me. It's right here. I'm going to, oops, I don't think you can see that. Hold on. There we go. It's right here. It tells us what it's going to do. Returns a correlation coefficient between two data sets. I'm going to double click on that, and it tells me it's looking for an array of numbers, followed by a comma, and then another array of numbers. So we're going to highlight our X values, press comma, and I'm going to highlight my Y values, and then I'm just going to hit enter. And here is my correlation coefficient, 0.968456. And you can see it's a positive number because as it appears, as the X values are going up, the Y values are going up. So that's why we have a positive correlation. It looks like it's very significant based on the fact that it is very close to the number 1. But we prove that by using this table 11, which is also included in Plato this week. And the first thing you need to do is find your sample size. Remember, n is always our sample size. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 ordered pairs. So our sample size is 9, so this is the row that we look at. And we look across to these numbers. These are our critical values, 0.666 and 0.798. If our correlation coefficient, which is 0.968, if it is greater than our critical values, 0.666 and 0.798, then it is significant that amount of the time. So in this column, we are talking about 95% of the time, and in this column, we're talking about 99% of the time. And we can see that our 0.968 is greater than our 0.666, so we are valid 95% of the time, or significant. I'm just going to put that critical value right here. Oh, no, that would go right here for 95%. And up here, it is 0.798. Those are the critical values that we are comparing against. And I put them in the wrong spot. I'm just answering my own questions here. So we're comparing against these numbers. We look to see if our correlation coefficient is greater than these numbers. It could just be greater than the 95 and not the 99%. But in this case, 0.968 is greater than both of them, meaning best case scenario, we are significant 99% of the time. Meaning there is a strong correlation, very strong correlation between hours spent studying, and test scores received. All right, I think that is all I wanted to cover for now, and have a good week.